Download this code from codegive.com, link in the description below. Buffer overread, a deep dive with Wikipedia example and code. Buffer overread, closely related to buffer overflows, is a type of security vulnerability where a program attempts to read data beyond the boundaries of an allocated buffer. While a buffer overflow involves writing outside the buffer's boundaries, a buffer overread involves reading outside them. This can lead to sensitive information disclosure, crashes, or even arbitrary code execution in more complex scenarios. This tutorial will cover 1. Understanding buffer overreads * what they are, how they differ from buffer overflows, and common causes. 2. Consequences of buffer overreads * information leaks, crashes, denial of service, and potential for escalation. 3. Common causes and scenarios * integer overflows, off by 1 errors, missing bounds checks, and format string vulnerabilities. For example, Wikipedia's zlib issue, illustrative will examine a simplified, illustrative scenario inspired by Wikipedia's past vulnerabilities involving zlib and how a buffer overread might occur during decompression. Note * this is a simplified adaptation for educational purposes and may not directly reflect the precise details of any specific historical vulnerability. 5. Preventing buffer overreads * safe programming practices, bounds checking, using safe libraries, and compiler mitigations. 6. Detection techniques * static analysis, dynamic analysis, fuzzing. 7. Code example, illustrative a vulnerable C code example with detailed explanations and possible exploitations. 8. Conclusion * summary and further learning resources. 1. Understanding buffer overreads. A buffer overread occurs when a program attempts to access memory locations beyond the allocated size of a buffer. This usually happens when array indexing is incorrect * trying to access an element at an index outside the valid range of the array. String manipulation functions are misused functions like strcpy, strcat, or custom string processing routines might attempt to read more characters than are available in the source string. Data structure errors reading beyond the bounds of a struct or object due to incorrect offsets or size calculations. Incorrect looping conditions loops might iterate beyond the intended range, leading to out-of-bounds access. The key difference between a buffer overread and a buffer overflow is the operation performed. Buffer overflow writing data beyond the allocated size of a buffer. This can overwrite adjacent memory locations, potentially modifying code or other critical data, leading to control flow hijacking. Buffer overread reading data beyond the allocated size of a buffer. This reads from unintended memory locations, which may contain sensitive data, garbage, or even trigger errors if the accessed memory is protected. 2. Consequences of buffer overreads. While buffer overreads might seem less severe than overflows, they can still have significant consequences. Information leakage the most common consequence is the disclosure of sensitive data. If a program reads beyond a buffer containing, for example, a password, it might read portions of adjacent memory containing other user data, cryptographic keys, or system secrets. This leaked information could be used for further attacks. Crashes and denial of service. DOS reading from unmapped memory or memory with restricted access permissions will likely cause a segmentation fault, seg fault, or access violation, leading to a program crash. Repeated crashes can result in a denial of service condition. Unpredictable behavior if the accessed memory happens to contain valid data, but not the data the program expected, it can lead to unexpected program behavior, including incorrect calculations, faulty logic, or corrupted outputs. Indirect exploitation. In certain complex scenarios, a buffer overread can be exploited to gain more control. For example, if the overread influences a later decision in the program, it might be possible to manipulate the overread target to control program flow. Bypass of security measures. A buffer overread can sometimes be exploited to bypass security checks or authorization mechanisms by reading privileged information needed to authenticate or gain access. 3 common causes and scenarios. Several coding errors can lead to buffer overreads. Integer overflows. An integer overflow occurs when an arithmetic operation results in a value that exceeds the maximum, or falls below the minimum, value representable by the data type. This can lead to incorrect buffer size calculations. For example, off by 1 errors. These occur when a loop or index calculation is off by 1. This is a very common cause. Missing or incorrect bounds checks. Failing to validate the size or length of input data before using it to access a buffer. Format string vulnerabilities. More often associated with overflows, but overreads are possible, using user-controlled data directly as a format string in functions like printf or scanf. Specifiers like %s can cause the function to read from memory addresses specified by the user, potentially outside the bounds of allocated buffers. For example, Wikipedia's zlib issue, illustrative. Wikipedia relies on zlib for data compression and decompression. Imagine a simplified scenario where a vulnerability could arise during the decompression of an image file or a database dump. Illustrative scenario *. Suppose Wikipedia stores compressed article content. When a user requests an article, the server fetches the compressed data and decompresses it using zlib. Vulnerability *. In this simplified example, the vulnerability lies in the fetch_compressed_article function. The uncompressed size is set to 10, but the actual decompressed data will only be hello, 5 bytes, plus null terminator, 1 byte, equals 6 bytes. Overread potential when printf, %s\n, uncompressed_article, is called, it will print the string pointed to by uncompressed_article until it encounters a null terminator. Since the allocated buffer uncompressed_data in decompress_article has a size of 10, and only the first 6 bytes contain hello\0, the printf function will read the remaining 4 bytes from memory beyond the actual decompressed string. This is a buffer overread. The data printed after hello will be whatever happened to be in memory immediately following the hello\0 string. Note * in a more realistic scenario, the overread might occur during further processing of the decompressed data, such as copying it to another buffer based on the uncompressed size. How a real-world zlib vulnerability might arise *. 1 metadata mismatch *. A malformed compressed file might have a header specifying an inflated size larger than the actual decompressed data. 2 integer overflow in size calculation *. An integer overflow could occur when calculating the output buffer size, leading to a smaller than required buffer being allocated. 3 custom compression/decompression code *. If Wikipedia used custom modifications to zlib or custom code around it, errors in that code could introduce overreads. 5 Preventing buffer overreads. Preventing buffer overreads requires diligent coding practices and the use of appropriate security measures. Input validation Always validate the size and format of input data before using it to allocate buffers or perform any memory operations. Check for reasonable ranges, maximum lengths, and expected data types. Bounds checking Implement explicit bounds checks before accessing array elements or using string manipulation functions. Asterisk safe string functions. Asterisk avoid unsafe functions like strcpy, strcat, and sprintf. Use their safer counterparts. Asterisk str and cpy and strcat take a maximum length argument to prevent writing beyond the buffer. Asterisk tinprintf is the safe alternative to sprintf. Asterisk use safe libraries and functions. Asterisk use libraries that are designed to be memory safe and provide built-in bounds checking. Many languages have standard libraries that offer safer alternatives to C-style functions. In C++, consider using std string and std vector. Asterisk consider memory safe languages. Asterisk languages like Java, Python, C, Go, and Rust have built-in memory management and bounds checking mechanisms, making them inherently less susceptible to buffer overreads and overflows than C/C++. Asterisk compiler mitigations. Asterisk enable compiler flags that provide security hardening, such as asterisk stack protector, protects against stack-based buffer overflows by placing a canary value on the stack and checking for modifications before returning from the function. This won't prevent overreads directly, but it can help mitigate the impact of overflows that might be related. Asterisk d_fortify_source equals 2, enables compile time and runtime checks for buffer overflows in standard library functions. This provides some protection against overreads caused by these functions, although its primary focus is on preventing overflows. Asterisk address sanitizer, ASAN, and memory sanitizer, MSAN, powerful runtime tools that detect memory errors, including buffer overflows, overreads, and use after free errors. These tools are invaluable for debugging and identifying memory-related vulnerabilities. These are typically separate compiler flags, fsanitize equals address and fsanitize equals memory. Asterisk code reviews. Asterisk thorough code reviews are essential to identify potential buffer overread vulnerabilities. A fresh pair of eyes can often spot errors that the original programmer missed. Asterisk static analysis tools. Asterisk use static analysis tools to automatically scan code for potential vulnerabilities. These tools can identify suspicious code patterns and potential buffer overflows or overreads before the code is even executed. Examples include Coverity, Fortify, and SonarQube. 6. Detection techniques. Detecting buffer overreads can be challenging, as they don't always lead to immediate crashes. Asterisk static analysis. Asterisk as mentioned above, static analysis tools can identify potential overread vulnerabilities by examining the source code. These tools look for patterns such as array accesses without bounds checks, use of unsafe string functions, and potential integer overflows. Asterisk dynamic analysis, runtime analysis. Asterisk debuggers. Asterisk use debuggers like GDB, GNU Debugger, to step through code and inspect memory contents. You can set breakpoints at locations where you suspect an overread might occur and examine the values being read. Asterisk memory sanitizers, ASAN/MSAN address sanitizer, ASAN, and memory sanitizer, MSAN, are powerful runtime tools that can detect buffer overreads. They work by adding shadow memory to track the allocated regions of memory and detecting accesses outside those regions. MSAN, in particular, helps find reads of uninitialized memory. Asterisk fuzzing. Asterisk fuzzing is a technique where a program is bombarded with randomly generated or mutated inputs to try to trigger unexpected behavior, including crashes or vulnerabilities. Tools like AFL, American Fuzzy Lop, can be used to fuzz applications and identify buffer overreads that might not be apparent through normal testing. The key is to provide inputs that might cause unusual size calculations, boundary conditions, or edge cases that could expose an overread. 7. Code example, illustrative. This example demonstrates a buffer overread vulnerability due to incorrect handling of string lengths. Explanation asterisk. One vulnerable function asterisk the copy underscore substring function attempts to extract a substring from a source string. 2 missing bounds check asterisk the critical vulnerability lies in the missing check to ensure that start plus len does not exceed the length of the source string. The function checks that start and len are not negative and that start is within bounds, but it fails to ensure that the substring being extracted stays within the bounds of the source. 3 strncpy asterisk the strncpy function will happily read beyond the end of source if len is too large, leading to a buffer overread. Strncpy will pad the remainder of dest with null bytes only if source underscore len is less than len. If source underscore len is greater than or equal to len, no null terminator is added, creating further issues. For exploitation asterisk in the main function, the call copy underscore substring, long underscore string, 5, 100, attempts to extract a substring of length 100 starting from index 5 of long underscore string. However, long underscore string is much shorter than 5 plus 100. This causes strncpy to read beyond the boundaries of long underscore string, resulting in a buffer overread. How to compile and run, and potentially trigger the error. 1. Save the code as overread example.c. 2. Compile without sanitizers, might not see immediate crash. With address sanitizer, more likely to detect the overread. 3. Run expected behavior without sanitizers the program might run without immediately crashing, but the output will include garbage data after the intended substring. This is because strncpy reads beyond the end of the long underscore string and prints whatever happens to be in memory at those locations until it encounters a null byte. With address sanitizer asan is highly likely to detect the overread during the strncpy operation or during the printf statement, and it will report an error message indicating an invalid memory access. The program will likely abort to prevent further damage. Mitigation To fix this vulnerability, add a bounds check to copy underscore substring. In this corrected version, the length len is adjusted to ensure that the substring being copied does not exceed the bounds of the source string. 8. Conclusion. Buffer overreads, while often overlooked, represent a significant security risk. They can lead to information leaks, crashes, and potentially be leveraged for more serious attacks. Preventing these vulnerabilities requires a combination of careful coding practices, thorough testing, and the use of security tools. By following the guidelines outlined in this tutorial, developers can significantly reduce the risk of buffer overreads in their applications. Further learning resources OWASP, Open Web Application Security Project provides extensive information on web application security vulnerabilities, including buffer overflows and overreads. https://owasp.org/ https://owasp.org *SENS Institute offers courses and certifications on security topics, including secure coding practices. https://www.sens.org/ https://www.sens.org *CERT, Computer Emergency Response Team provides information on security vulnerabilities and incident response. https://www.cert.org/ https://www.cert.org address sanitizer, ASAN, and memory sanitizer, MSAN, Documentation * explore the documentation for these tools to learn how to effectively use them for detecting memory errors. Textbooks on secure coding * consult books on secure coding practices for more in-depth coverage of buffer overflows, overreads, and other vulnerabilities. By understanding the causes, consequences, and prevention techniques for buffer overreads, you can develop more secure and reliable software. Remember to always validate input, perform bounds checks, use safe libraries, and leverage available security tools to protect against these types of vulnerabilities.